Hello everyone, this is the video lectures for Math 1314. I am Professor Burrow and I'm going to be using the workbook with you guys here. So often my lecture videos on YouTube don't use the workbook. I'm wanting to use the workbook here because it's a little bit more official. It kind of stays in pace with the class and hits up the concepts that sometimes my other lectures that focus on the homework maybe not always hit up. So let's go through this together. It'll be great fun. Now I'm using the 6th edition, so just in case now you know, and here we go. So starting in P1, it says, what's a variable? Variable is X. Yeah, that's it. There you go. Well, I mean, it's really just a letter that represents some numbers, any numbers, all numbers. It kind of depends, but we use X most of the time. So when you think X, think variable. Whenever you think variable, think X. It's good enough. Math expression or an algebraic expression is numbers and X. And again, X could be anything. It could be Y. It could be all kind of different letters. They also have operators like plus and minus, divide, fractions. We got exponents, all kind of stuff. But if it looks like a thing from math, then it's probably an algebraic expression. So there you go. There's my Chad definitions for that. Let's do the first example. So it says evaluate, as in whenever it says this, it means plug it in. Plug it in. So I'm plugging in 7 in for X. So right here, this will be a 7. This will be a 7. You replace them with 7, and here we go. So I got 2 times 7 plus 3. And then in the bottom, 4 times 7 minus the 12. So I need to work on this, like simplify it down. And again, we got parentheses, so we should be doing that first. Notice here that I have a parentheses around the 7. What I'm really saying is like multiply. You could do this a couple different ways, like with a dot or a little time sign. But I typically use parentheses for multiplication. See, it's also happening up here. But inside first, and then you work outward. We got a 10 on the inside. When we're multiplying here, we get a 28 minus the 12. And then 2 times 10 is 20. And 28 minus 12, I believe, is 16. So they're wanting to simplify this down. I'm just going to tell you the answer. It's 5/4. Basically, you cancel a 4 from both of them. But notice I have Desmos up here right here. Desmos is super awesome because it can do most of this for you. And that's a good thing. Notice I typed this in and, oh no, I got a decimal. Well, if you click the fraction button, there's your answer. We're good to go. So I think it's really good that we can simplify numbers, of course. I mean, we should be able to be doing from here to here without Desmos. But I also want to show that Desmos is available to you, and it is nothing that I'm going to shy away from. Some other things, since we're sitting here, let me show you that you can type in even the original in Desmos, and it will do it for you. So you can even just type the whole darn thing in there, and it'll give you the simplified fraction. Very cool, very cool. I want to show you something else here, though. What you could do is you actually type the original with the X in there. Desmos is smart enough that you can do something like this, and then it says, what is X? Well, X equals 7. And then again, there's your answer. So you could not have to write anything down. Wow, that sounds so cool. But I really don't think that's always the best way, because there will be other problems in the future that Desmos won't do for you. So I'm just saying that I don't want to shy away from it. I want to use Desmos with you. I want to show you how to use it, but I won't use it all the time because there are other things that we need to be learning, not just a calculator. So let's keep going. And just here, for example, yet again, we can just use Desmos right now, and I will right now, but I'm going to go back and do it by hand to prove a point. So here we go, x, y minus 3x. And then I got x equals -4, y equals 4, and it gives you the answer. It's perfect. Okay, so there's your answer. It's 2. We're done. Moving on. Well, let's go and do some math. I want to show you some of the processes. So here we go. I'm going to say 3 times, and my x right there is a -4, and then I got a 4 for my y right there. X times y would be -4 times 4, and then 3 times again a -4. So if I just did this in Desmos and that was it, I would miss a lot of these concepts, which will be important later. So right here, when I'm multiplying with a negative, I should get a negative. Yet again, I got one negative, so I should result in a negative. But here I've got two negatives, I should get a positive. So those little things that we take for granted, now we can see them. Here I have a negative 8, and then in the bottom I have a negative 4. Notice that two negatives will cancel and make a positive. So positive 8 over 4 is a 2, which we already had, and we're good to go. So I'm going to go back and forth between it, okay? That's my point. Cool? If you have questions, I don't know, ask me. But I'm going to keep moving because obviously this is just a recording. So new concept, new topic here, absolute value. I would say that this is always positive. Always positive. Let me go through a couple examples before we hit up this problem right here. So let's just say I had absolute value of negative 4, something like that. Well, the answer is positive 4. What if I had absolute value of negative 100? Well, now it's a positive 100. What if I had absolute value of 3? As in positive 3. That's the original is positive. It's still a positive. It's still a positive 3. So if it were negative, you make it positive. If it was positive, you leave it a positive. And lastly, what's the absolute value of 0 is 0. I mean, it's still the same number. It's just that we need to have it positive in the end. And so with that, it says rewrite without absolute value signs. So just being silly, ta-da, we're done. No, I'm joking. I just did it literally, right? No. So I want to see what they're talking about here. They're wanting to make it simplified, I guess. We'll see. Notice that it says exact answer. We're not looking for decimals. So to show you what's going on, I actually want to just find out what that number is on the inside, and the best way is to use a calculator in this particular case. So let's just say I was going into decimal land, and the inside of this is supposed to be negative 5.26. I'm not rounding it properly, but that's the point. Okay, so we got it. Negative 5.26 on the inside. Great. Well, if I were to make the absolute value of that, it would have to now be a positive 5.26. So we're cool there. Yeah, that's my answer. Yay! But they're still wanting to use these radicals and stuff. Radicals meaning the square roots. So I can't just put this in the box and hope for the right answer. I've got to, I don't know, re-simplify it or unsimplify it or whatever you'd want to call it. Go back to the original style here. Okay? So I'm saying that this thing here goes from a negative into a positive. Awesome. What if I were to somehow manipulate this to get into a positive but without the absolute value signs? As in something we just did a second ago. What if I were to make it two negatives will make a positive? Now notice what happened here. I did not use the absolute value signs. I basically just said, well, the same effect happens when I do two negatives will make a positive. And so that's what the goal is here. Well, we know this. We know what that thing is right here. That was our original inside. And so what I'm doing is I'm applying a minus sign on the outside to change its sign. And so when you, I guess, distribute your negative, we have a negative square root of 3 and now plus the 7. That's your final answer right there. And so there's a couple ways you could do this problem, of course, but I recommend it that way. You're looking at it. You're saying, I need this to be positive. How can I make it a positive? Well, two negatives make a positive. And so that's why I just replace it, distribute, and there you go. So, cool. I know it's a little bit complicated of a problem, but it's really it's a one-off problem. On the homework, you just do it, and then you keep moving, okay? You got a lot of other problems to do. I wouldn't spend too much time focused on that guy. Like this guy here. It says, hey, go ahead and rewrite the expression without absolute value signs. Same kind of thing. This one here, though, I don't think I have to go and do anything tricky. I could just look at it. So I'm going to rewrite it. And I got to say, this is the most, lines. Look at all these lines. And then I got a circle. Just stepping back, it just looks kind of funny looking. Absolute value of negative 10 is a positive 10. So I'm just going to write 10. Right here, absolute value of the negative 11 is a positive 11. But notice one thing is that this minus sign was not yet applied. I'm not yet using it. I was only using this chunk and this chunk. That was it. I hadn't yet done something with this thing. Now I will. 10 minus the 11 is actually a -1. And now I said, what's the absolute value of -1? Again, it's always positive, so it's +1. And again, in like my math lab or something, you would just put 1, and then you're done. I kind of messed that up a little bit. That's just my sound effects for the eraser. This eraser is not that very good. I'm just going to say, erase? Why don't you want to erase? Well, we're learning together. So just don't make mistakes, Chad. Oh, no. I was wanting a positive. See, there you go. That's why you have to have erasers. Are y'all ever using a pen to do math? No, don't do pens. Always do a pencil because you should erase it. And it's not erasing. Well, that's why we just scribble through it. The +1, we're good. Good enough. Okay. Can you do this one in Desmos? You can, actually. This one. But it's kind of weird. Notice that I want to do open, like 2 absolute value signs, and Desmos just is like, you need to put something in there. So it is acting kind of weird already. And then I guess maybe I can go back and do this. Okay, there we go. So like after a little bit of work, I did get it. But like if you're not like a Desmos professional, I would not go down that road, honestly. So let's keep going. It says evaluate. Well, again, we're just plugging it in. So my x was a 9 and then plus, and now I have a -6. And so like it's plus a negative, that's technically just a minus. 9 minus 6 is a 3. Absolute value of 3. Again, this is +3. You always keep it positive. It's 3. That's it. You're done. Cool. So easy stuff there. Next topic. And so it says simplify. Now, I got to say, none of this is possible in Desmos. Everything that we've been learning so far is, you can pretty much use Desmos on most of it. But like it says, okay, go simplify. Come on, simplify. And it does not understand at all. So the concepts that we were learning above help us with these problems here that are not capable in Desmos. And that's a good thing. That's fine. So let's start going through those processes here together. First off, I want to distribute. Distribute. So then 7 times 3 is 21y. And then 7 times 9 is 63. Again, distribute the minus sign. So I got a -7y and now a -2. So distribute is the first thing that we're going to do. And then the next thing after that is combine like terms. Combine like terms. And with these problems here, what you're going to see is that you distribute, combine like terms, distribute, combine like terms. You just kind of alternate back and forth between them all the way down until it's done. So that's what we're going to be doing here as well. Combine like terms. So these y's hang out together, and then the numbers get together as well. So my y's, I now have 14y. And then here I got a -65. There's nothing else to do, and so we're done. And there you go. Let's do another one. So this one looks pretty crazy, but I think we can get it. First off, start from the inside and work out. So that 2, I'm going to distribute the 2 first. And I'm going to try to write a little bit tinier because this is about to get crazy. Notice that this one has like those brackets. That's just a fancy parentheses, honestly. It's the same as saying those are parentheses. So don't overthink it, okay? But if you start using like brackets in here, Desmos just starts freaking out. So if you see brackets, it really just means parentheses, and you're good to go. Numbers combined together. And again, I don't really have to rewrite the whole darn thing, but it is best practice to do so. So distribute. Notice that we keep on distributing, combine like terms, distribute, combine like terms. 2 negatives make a positive there. Now we combine like terms. So 12 minus the 2 is 10. And then 8 plus 3 is 11. And there is your final answer there. Cool. Let's do the next one. So I'm going to start with this minus sign. 5 minus 4 times 2 negative, and 2 negatives make a positive. Combine like terms on the inside here. So these numbers here get together. Notice that's a +2, and that's a +8. So that's going to be a +10. You could put it in the back or the front. Either way is fine. Distribute. I'm starting to run out of room. Negative 40, two negatives make a positive. That's a 36y. And then finally, again, combine like terms right here. I'm going to put the y in the front because it's traditional. Here we got a negative 35, and we are done with that problem. So all of that there is totally impossible in Desmos. It truly is. Even if you pulled up Desmos graphing or something, it just ain't going to work. So what we are doing is using that stuff we had from before and applying it on these kind of problems. Okay, application. So I don't know how this is applicable to you, but hey, you know it's cool because it's words, right? Word problems. That's what they mean. They mean word problems. Yay. Um, so it says rewrite using math, and x is the number. So I'm going to start going through this slowly. Every piece means something. So it says difference between. Okay, pause for a second. Difference between means subtract. And so what I'm going to do is have two things, and I'm supposed to subtract them. So difference between is thing minus thing. So let's start with the first one. It says 5 times a number. Now it says that number is supposed to be x. So 5 times x, 5x. And so this is like the conjunction thingy. Again, I don't know. I'm a math person, but I'm combining or putting them together with the and. So now we're on to the next phase. It says 4 more, pause, 4 more, 4 plus 2 times that number, 2x. So now I have to do this thing minus that thing, and there we go. I have to say that this is actually the answer to part A. It says do not simplify. That's actually what you would put in this box right here. But on my math lab, they want you to keep going. They want you to simplify for part B. So part B, we got to keep going. I'm going to distribute, and you don't need these parentheses, so just 5x minus the 4 minus the 2x, combine like terms. So we got, what, 3x's minus the 4. There you go, and we're done. Awesome, awesome. This guy, definitely a Desmos problem, but I think, yep, that's the last one. So let's just get this section done. I'll stop the recording, and then I'll start it back up for the next one coming up in a second. So we have this crazy formula, and they're saying that X is years after 2000, and then they're talking about 2010. And so I have 2000 to 2010. How much X do I got? It's 10. Very good. And so what they're wanting is x equals 10. I'm going to plug it into the formula and get the answer, essentially. Now, there's a lot more besides just this part, but I at least want to show you this one. What we're going to do is plug in the 10. It looks like 26 times 10 squared plus 813 times 10, and then plus the 15,654. If there ever was a time to use a calculator, it's now. So let's do that. 26 times 10 squared plus 813 times 10, 15,654. Awesome. 26384. There it is. We're done. And that's part A. I can't remember on what my math lab, what they had for part B and C, but I'm going to try to remember it a little bit. I think that we're going to compare it to the chart. And so you can see in 2010, this is what the actual amount was. This is the actual amount. And this is like the expected or the formula, the model. The model, that's a good name for it, or maybe just our number. And what we're going to have to do is compare them. And essentially I'm saying, well, which one's bigger or which one's smaller? Like, is mine bigger than theirs or is mine smaller? So if you look back and forth, mine is actually bigger by a little bit. So part B, I'm going to say, not my, but mine is bigger. Come on, eraser. Yeah, there you go. Okay, so mine is bigger. Mine's larger. So there's like a, I don't know, it's like a button, and you click which one is it bigger or smaller. Mine's bigger. So there you go. Part C, it will say like by how much. And so that's when we start subtracting. So I'm going to get the 26,384. That's mine. I'm going to subtract it from the 26,378. And again, I could probably just do this in my brain, but I just want to make sure that I'm doing it right because I'm being recorded for YouTube. And so I got 6. So 6 is the answer. So by how much? $6 difference. All right. That's all I got for this video. Thank you very much and have a great day.